Hello, hello. Okay, we're gonna see if this is all streaming. I'll make the appropriate announcements. Well, Pink. Hello. Hello. All right, let's do a couple things. Okay. And then we'll go see if anyone's signed on yet. It's possible that no. My dog's out. Yeah, yeah, they are. Okay, great. Let's go get those away. Can you see this? Mm-hmm. Barely. Here's when I hunch. Okay, one more second. This is weird. That's right. Yes, I know. This I know. Come on, bro straps. All right. Ding, 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 ding. Okay, I gotta open up Twitch to see if anyone's here. I don't think anyone knows yet, unless you're on the schedule. So if you are on the schedule and you're here already, welcome and thank you. Otherwise, we need to make all of the announcements. So, first things first, AJ gets his brain on. We open up Chrome. It's on a secret tab. So I will give you a picture of a cat. English, please. I'm in Thailand. Picture. Let's go with kitten GIF. And just while I get some stuff sorted out, let's go with this one. That's great. Hello. Error. No. Yeah. Just hang out with me for a sec. I'm gonna sort some things out and we'll be good to go. Mostly just notifications to people. Shut TV. How was your weekend? I guess it's the start of the weekend, but I hope it's been good. I hope you are happy and healthy. I hope you are here watching my channel late at night in Europe, in over dinner in North America. If you're not here yet, that's okay. We're obviously going to record. We're going to send these things off as soon as I let everyone know that we.
He's threatening booking one in which he would win a queen, but
Let me check out my channel.
queen.
Check out my channel. All right, there it is. Yeah, we got it. We're live. So time to let people know. So we're going to pop into the Discord. We're going to say here. Let's go awesome announcements at awesome. Live stream 4 is up. Mhm. We have 7 people interested. We're gonna have to let them know manually. This location. We have an event, but because I don't have access to the other account, we're going to edit event. Huh? Well, we're gonna copy the names of these lovely people who are interested. See a rubber SCP. See, interesting. Hey, the live stream is over here. Hi. Hello, hello, hello. Okay, anyone who showed personal interest in the event, yes, I'm a human. Served warm. That'd be soup. My gosh, I'm so good at captchas. It's like food normally served warm. Soup. Let's go, dude. And last one. Okay. Hey, yeah, get out of here. But cool. Last thing I gotta do is change this event, end event. We have changed our URL, so I have to add an event for today and update the link to be this link, and then we are good to go. Okay, let's just say next. Save event, save event, and then we have one today. Create event starting somewhere else. Here, link, boom, next, starting immediately. Going till about, maybe it's like 9 today, because I have a friend's birthday. Does that make sense? 9 should be chill. And we'll find that photo of me, my little face. Icons. All right. And then we are going to post in all the other places, and we are set. Live coding, part 4. Yo, done. Okay, let's go. We're gonna drop this in the cam. Heyo, they're live. Yes, awesome. Live coding, part 4. Done, done. Let's check to see if we got anyone right now. Ooh, a juicy one. Hello, welcome. And we're just gonna post in a couple more places, let folks know we're up, that we are awake, that life is happening, and we should be really on our way. Going to x.com. We are live on Twitch right now. Live programming the awesome. Twitch account is Research and Desire AJ. Create a post. We are live right now, baby. Oh, I got 4 people. You're so sweet. Y'all love every time you come in. We're just taking 2 seconds to make sure we let all the channels know that we are on, that we are live. So in the meantime, I'll give you an anecdote. I lost my tripod, and by lost, I mean I donated it to a local art house. And the consequence of that is that my current tripod is double-sided tape. Yeah, stuck to a hamper. That's what I do over here. That's my life. It works though. So I can't complain too much. We are live right now. Hey yo. And linky. Okay. And then we'll get started. We will let everyone know what is up, what the plan is. So post it on X, post it on FET, post it on Reddit, Instagram, I don't have access to yet. And should do email. I could email blast. We in the mood for an email blast? I think, yeah, fuck it. Fuck it. Almost there, folks. All right, subject line. We are live. Coding the awesome now. Sender's name. Pre-header. Choose email template. We are going to go so fast, and then we're going to be flying. I'm going to open chat here. How's everyone's week? What are y'all up to? Oh, did I freeze? Freeze? No, I did not. Freeze? No, not. Freeze. Yeah, use template. It's an Easter template. Screw it. Yeah, use template. It's an Easter template. Screw it. Use template. It's an Easter template. We are live on Twitch right now. Twitch right now. Come join us. Trash. 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 Thanks for your patience, folks. Thanks for your patience, folks. Patience, folks. Okay. So interesting. I can just hear myself. The latency is like just perfect. That it's almost the voice jammer thing. The latency is like just. Oof, careful. Scary. All right. Email is almost sent. Done. And send. All right, folks, we are set. Let's catch up here. Let's figure out what we're up to. I'm just going to grab my coffee, and then we are good to go. So we're going to switch over to freeform. So let me go get my desktop set. We're good to go. Awesome. So here's this. Let me just rearrange so I can see chat and and my dumb little face. Test. Oh, it's so fast. There we go. Life is good. Life is good, folks. Good stuff. All right, I can see chat. I can see the things I need. We are happy. We are healthy. We are ready to go. So here's what is up. I am pre-coffee. We're gonna go get some coffee. It's downstairs. Oh no, there it is. It's right there. And then we're going. Pink. Bum, 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 bum. Ra-da-da-ra-da-da-da-da. Okay, we're just recapping where we're at. So, for those who have no context, zero context, we are creating a bit of an MVP. We're trying to do it all live on stream. And this MVP that we're going to work on is a pattern playback mode for the awesome so that you can create, design, share, and distribute patterns where these patterns are saved on device, are part of Stroke Engine, are distributed the exact same way as Stroke Engine so that, say, the radar, the dashboard, the online web tools, just anything that parses the list of pattern names can find and replay any pattern that you want. This is the objective. So what we've created so far is we have a very rudimentary but acceptable or first pass of a dashboard modifying tool. So like up here, let me find the image. This is our raw, but this is roughly it. You drop these points and you create a cubic spline pattern. It's got the handles. It's got everything you expect to see from this sort of interactive thing. Let me just mute my stream so I can play it and make sure I'm not crazy, that I'm actually streaming. Awesome. Okay. Hello, come back. All right, good stuff. So we have this. It is missing a critical component, which was this BlueJ right here, the BLE utility. The BlueJ, again, those who've been around, you know that we are using Freeform, and Freeform does not have a good icon pack. BlueJ is Bluetooth, so that is our life. However, we're not concerned about that part. In fact, it's going to be the easiest part. So we're moving past. We're skipping, and what we're jumping to, or have jumped to and completed, is from these blocks at work. Let's go down to this one. We jump down to actually just storing the patterns on the awesome. So what we've done is we've created a registry file and a directory called patterns, where the registry knows every single pattern that's saved, and then you can load up the pattern file on demand instead of storing it in memory so that your list of patterns could be very large. Definitely not infinite. Classic ESP32 memory problems will immediately arise, but it will be large because we're pulling these dynamically. These will be attached, and we're successfully completed this part, attached to the end of the list of stroke engine patterns. So you'll have your 7 stroke engine patterns and then all the ones that you've saved. They are going to be version controlled, not in MVP, but what is in MVP is that they will play back. And we did a little bit of conversation on how this playback should occur. We've chosen the simplest path. The simplest thing to do is we're going to find the 2 nearest points. If you're drawing an arbitrary curve, we're going to first guarantee that it is probably C2 continuous, but definitely C1 continuous, because all physical systems will be definitely C2 continuous. Can you say always continuous in all spaces? Like C3, C infinite? I don't know, but that's a question I'm going to have to look up later. Certainly, we know we must be at least C2 because the machine does not have the ability to instantly change its acceleration. Yeah. Hmm. Okay. So what we decided is if the user is drawing a bunch of points with handles for their spline, then we're going to look at the 2 nearest points inside of that curve. And we're going to define that as we have to improve our calculation here a little bit. But we're going to reverse engineer the pattern such that the two nearest points can be traversed as if it's 100% of your stroke range at max speed. What's the consequence of this? There's a couple of things that will come out of it, some of which I can foresee as being problems. For instance, what if you do very close points and it's a short distance? Will this have a scaling issue for the rest of the pattern? Yes. Are we concerned for that case today? No. Right. So what we're doing is we're scaling the entire pattern by the shortest possible distance with the shortest time command, and we're guaranteeing that given the physical limitations of the device, you can complete that transition as if it's the entire range, which then guarantees that you can complete the entire pattern. So it gets rid of any issues with, say, Nyquist frequencies where you do this and you're sampling your regular pattern at irregular points, making a new pattern. This would not be a problem because we're guaranteeing based on the scaling that you're going to be okay. The other choice that we made last time is we're going to be sampling the curve, the spline, at 10 hertz, 10 times a second. Now, we know that there are a couple of concerns whenever you're doing this sort of sampling. The first concern is, well, there's two major ones. The first is the action cue on the stepper. When we say go to this point, there is a buffer. Maybe a cue is the most appropriate statement here. I'm not sure if the stepper code is written in C++, C, or something else, but let's talk just simply about this command buffer. We know there is a list of things that when we say go here, go here, go here, we can overflow it, we can send it too much, it can stall, it can miss messages. 10 hertz in practice seems to be totally fine for not overflowing that buffer. Perfect. Quite happy. The second thing that's a little bit annoying, which we have not accounted for and not solved, but we do need to be aware of, is here. There's a trapezoidal motion pattern, which I believe lives inside of Fast Excel Stepper, our stepper controller library. There is a chance that part of this trapezoidal motion control is inside of the stepper control code itself. I need to do a little research on that. But what we do know is that if you sample or if you drive redundant commands, simply put, it feels bad. Like it feels physically bad on your body. It's choppy. So right here on the left, I have this example where if I were sampling essentially a trapezoidal pattern and sending 4 go to this point messages when 1 would have been sufficient, then this on the left will feel physically worse than this one on the right. The left one will simply feel choppy. We don't want that. So we're going to keep an eye on it because we are taking the approach which has the highest risk of this choppiness. We're trying to keep our headspace in MVP, close the loop, deliver to the humans, let the humans do the good things. You are the good people. You will save me. That's my dream. All right, here we are. So we did all of the work that we need to do to get this running in the minimum. You may, right now, if you want, flash this branch onto your device. This is not production ready, but if you have an awesome and you're in the mood, you are awake. Yeah, my current working branch is AJ/awesome-patterns. And unless I'm crazy, or unless something broke inside of our pipeline here, you might be able to flash it on our documentation website. If you do choose to join me and flash your code, explore a little bit what we're working on, flash this development code, please make sure that you flash back before play. Until we merge this and do appropriate testing, this is considered, unsafe. All right, we do not have it here. All that means is there is a small break in the pipeline. So just check out this pattern, this branch, and I will fix the web flasher in the future. So we're going to get our setup going again. I'll pull my awesome into frame, rearrange a couple things, and we'll keep going. But our qualitative problems that we had assessed from our previous session were as follows. Right, the max speed calculation seemed too timid. I know for a fact that this awesome can go much faster. So we have to figure out why that's the case. Almost certainly, when I did a manual calculation above, which was here, it was not taking into account the fact that the play range is actually shorter than 300 millimeters. On a standard stock build awesome, it's probably closer to 22 millimeters. Sorry, 220 millimeters when you include the buffer zones. And, you know, the rail is 300 millimeters. The play range is like, yeah, about 22. That's the first thing that probably threw us off. The second is, yeah, it's a good question. I'm not sure. But what I do know is that we're going to modify our calculation for how we're scaling the entire function such that it is moving. Again, the condition we want to maintain is that the two closest points on your curve are physically achievable. That's it. On your device with your calibration. That's what matters. Bum. Okay. Right, so we're gonna use the home play range instead of the rail length. Perfect for determining these calculations. This one was an interesting one. So again, I'll get myself set up in a sec, but this other issue, speed changes are not continuous. This was very interesting, and it makes perfect sense why it's the case. It'll be an interesting one to resolve. I'm just gonna restate the issue by pulling this curve down. Okay, so if this is our curve and we are here, right, right, let's go here. Then we might want to change speed, which has the functional effect. Let me see if I can do a dashed line or something, and we'll change it to orange. But yeah, dashed line for anyone who's colorblind. 1/4 of AMAP is what I've understood. All right. So if I change speed and I'm at this point, what's occurring when I state that speed is not continuous is right here. Boom. What happens is our speed jumps quickly. Changing the speed has the functional effect of changing the frequency, shrinking horizontally our function, our spline. And so as the speed changes, the functional value, your current speed, just jumps. What must occur, non-continuously, I should say, it feels very jarring. What must occur is that instead, simply, we do this. We anchor the new function, your scaled function, at the same point as your current red value, so that your current speed is identical, i.e. your current point upon that new graph is identical. So it's a horizontal shift. Where do we get our, yeah, good question there. Sin City Jesus. Whoa, what a name. Love it. So I'll tell you personally what we do to get our VacuLock compatible toys. Let me take a look here. We get a diamond drill bit. I think it's like I think it's literally a product for this called like the VacuLock drill or something. But I'm gonna show you. I am going to from memory, so please fact check me. I think it's a 25 millimeter diamond drill bit for coring. This looks approximately right. Please fact check because I am going from memory. And what we do is we take, it is, I believe, fully hollow. So this pin is not here, not the one that we use. And truth be told, you just slap this bad boy onto the end of your drill. Take any medium, even a soft silicon dildo, and you core the dang thing out. You just, of course, you can't get down to the bottom. So what I did was I just put my finger in there and I twist and snap, and it comes out. I'm gonna go find you the video, and I will share it in chat. There should be VacuLock coring video. Man, I gotta change the default language. It's just my guest account isn't there, right? Nah, that's not it. If I don't find it in like 2 minutes, I will absolutely just send the link into Discord later. But vacuum lock. Let's do like dildo coring, dildo video, dildo core drilling tool. Wish me luck. We're trying here. Ah, let me in. That's crazy, man. That's what I get for being on guest mode. All right, so this is like the correct tool, to be clear. It's not the one that I use personally, just because it's harder to get access to, but this is like the one that you're supposed to use. It goes more than deep enough. Is this sold by Top Toys? They're also Canadian. Love them. If you're ever in London, we have only one physical location where you can buy R&D products, and Top Toys is on the shelf beside us. I love it. That company is called Regulation in the UK, downtown London. Big fans. Anyway, this is your answer. Let me send you this link. I am sure you can find it in 101 places. Oh, let's go. Yeah, no worries. LFG. All right, back to this. So, right, this is problem number 4. Right. And the last thing is going to be April tag for error detection. Then we also want to add in stroke and depth. Quick sidebar, April tags are these bad boys. I have a whole system for local debugging where, oops, where are you? I'm gonna go here. I'm gonna go camera. It's my least favorite camera, but there we go. We do what we must. This guy. So this is an April tag. It is good for uh, three-dimensional positioning of, it's essentially a robotics tracker that helps you with three-dimensional positioning, including angle relative to camera. It's super great. I use it locally to debug position. So you set up a camera feed to watch it, or you record in slow motion, and you replay the video under a Python package for April tag tracking. And it tells you exactly where the awesome is. You can compare your send command to what actually occurred. Fucking love it. I would love to do that in this context to make sure that we're on track. But we also still need to include stroke and depth, which I'm going to raise the priority of. These are going up. Ba-bum. Okay, first things first. We have to repair my awesome. So I'm going to leave these things here. These are our to-do items. And by repair awesome, I simply mean I take it around sometimes. Take it to friends' houses, show it off. I recently had it living at a little art house, a little art display, and now it's in pieces. Also, I've been advised by the wonderful armpit that I've installed the pick clamp backwards, so we're just going to fix that now. It's going to be brief. Here we go. Hey, folks. How's everyone doing? Love seeing people pop in and out as you're living your life. Where are y'all from? Cambridge, Massachusetts? If you watch Dropout TV, it's a great joke. Truthfully, if you don't watch Dropout TV, I hope you do. It's a great show, one of my current favorites. Evolved from College Humor. Anyone out there who's an old geezer like myself, definitely remembers growing up on Jake and Amir challenges. All right, let's go. All right. Yeah. Can you see this? We're just barely in frame. We're barely in frame. That'll do. Okay. Actually, I think let's go for it. I was considering whether or not to do this right now, but we got a kind request from Burns. Got a kind request for some folks in the community to correct the orientation of this thing. Just make sure no one gets confused. They watch these videos back. The only one who should be installing things poorly is AJ. So we're going to keep that true. There we are. Okay. A little bit of repair. AJ's breaking his stuff. All right, so I think today we're gonna be able to get pretty far. Again, is anyone gonna, out of curiosity, we've got 7 folks in here right now. I've got the branch name. Is anyone in the mood to flash the branch with me? If you are, just let me know in chat. It'd be very, very interesting to give somebody access to my development environment. So just running off localhost, just see what your experience is, kind of get some feedback live. If you do have your awesome just set up right by your computer and you're in the mood, you are so invited. It'd be, in fact, cool AF. Oh, can never figure out my bra straps in this thing. I like having the apron. I want to keep it, but drives me crazy. Drives me crazy. Here we are. So that is now, well, one part of that is now correctly mounted. I'm going to reverse mount this just for my own convenience. But hey, c'est la vie. Okay, pick clamp, correctly mounted. Chip, awesome chip. Ah, there she is. So it is currently April 11th. Today is my friend's birthday and also the beginning of the new year in Thailand. So for those who don't know the lore, I am currently, so I'm Canadian, company's Canadian, we're all Canadian, but I'm currently living in Thailand, just vibing, working on this machine. Here, it is a poking machine. There's a wonderful Mickey Mouse hand here, or a wonderful bleep bleep. Please don't copyright me. And this is my PG-13 version of this product in all public spaces. Not that I work on it in cafes or something, just hey, the occasional co-working space, friend's house, stuff of that nature. But yes, so today is the start of their new year. There's so many events happening. The biggest thing is everyone pulls out a water gun, like childhood level water gun, and runs out into the street, just starts going crazy on each other. And I'm looking forward to that. I think the chaos is going to be rather fun. All right, we got awesome in frame. We got awesome hooked up. Next thing is we're going to just load up the latest firmware and explore the tool a little bit, resolve some of these first 4 issues, make sure that it is decent, like is roughly moving appropriately, and then go from there. Let's go here, switch in frame on that side, and I'm gonna need access to user. Oh no. Oh God. There we go. Okay. Perfect. 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 And do I have the perennial problem of having one too few chords? Yes. Yes, I do. I need one more. One gosh darn more. Okay. Camera one. Sorry. Sorry. See you in a sec. You're going blurry. Sorry. A little bit of light. Brilliant. Boop, 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 beep, boop, 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 boop. Okay, what do we got? We'll sip of coffee. Ah. Bum, bum, bum. That is set. I need one dang more USB-C cable. So I gotta get up. It's over there. Okay, let's go. 1, 2, 3. Mm, mm, ba-bum, bum. All right, folks. I see names coming in and out. So I'm just going to keep roughly reminding folks of the strat, the plan. We are working on live coding, pattern, drawing, and replay on the Awesome. All lines of code are going to be uploaded to YouTube, or like the entire process. Nothing's going to be written off screen except for the polish. We're pretty close. We got things working. So, as you live your day, live your life, keep me on in the background, do your laundry. It's evening for most of you, late night for the Europeans, and very, very, very early morning for the Australians. There's, in fact, no convenient time for everyone in our lovely community. So I'm going to move these around every now and then. But for now, it's convenient for no one. No one. All right. Here we go. Popping in. We've got our thing running over here. Let's go. Let's hide this. Let's get a little freedom. Too much stuff in my space. Close all. I should be terminals. Let's go. First things first. PIO run. Let's just get some code on this thing. So I got it plugged in incorrectly. Chill. PIO run. I will show you all the issues one by one listed on the left here. And we're going to, just talk about it, understand the problem and what the solution needs to be. Now, I also need one more gosh darn USB-C cable. Currently I'm using, this is not a lot. It's not a lot. It's just more than I ever need on a daily basis. I have 1, 2, 3, I need a fourth. So much electricity. This is the matrix. All right, she's flash or flashing. Let's go find it. She won't move because it's not plugged in. Cable. Looking for the cable. Oh. Stick on the shirt. Okay. Not the kind of show, folks. You won't see me without my apron. I don't know why. I'm just weirdly committed. Weirdly committed to the apron. See it. What'd you say? Oh, dang. It's always like a little nice and a little sad to receive spammers. Yeah. Possible ban it. All right, let's just ban this, bro. Gift Turbo. Could you imagine? Yeah, we are ban. See you, buddy. Da, 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 da. I wonder how that works. Must just be like a constant stream. Oh, hello. Yeah. Hey, how's it going? Don't worry. I think we did a quick ban there. Hopefully you don't see that message anymore. Nico Geiger? But yeah, nice to have you, Nico. You're super welcome. Welcome to be here. I hope you have a coffee if it's morning. I hope you have anything else if it's not. Chat is paused. Wow. Yeah, good to go. We're reset. Life is good. We are stealing this USB cable. We need power. We're plugging into the main. Let's go. And let's do a gentle reset here. Bum, 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 bum. Let's recap these issues. I just gotta remember to look up. I put the camera over there because it looks better. Yeah, that is correct. Ah, sure thing, Nico. 2 a.m. All right. Yeah, European time. Well, make sure you get some sleep tonight, but also thanks for being here. Don't leave me. Mm, good. I'm gonna keep trying to workshop it. Maybe do like a bunch of different stream times, like a European convenient, North American convenient. I think this is probably North American convenient. It's like after work, 7 p.m. Currently working on 8 p.m. But it's definitely not Euro convenient, and it's definitely not Australia convenient. We'll work on it. We'll work on it. Okay, so here's where we're at. I'm going to show you what's up. I'm going to switch cameras for a sec. Let's go camera 5. Going to keep open OBS. So it's called 6 now, camera 6. Hello, hello, here we are. So you can see here on the screen, I'm going to switch down to stroke engine. Let's see if I can do this reverse. Inside of stroke engine, we still have our speed limit. Let's go change this down. And if I double click, boom, boom, I can see my patterns. And importantly, when I, reverse mirror world. When I scroll down, you should see test 1 and test 2. Yeah, test pattern and test pattern. So I'm going to click into one of these. Both of these are simple trapezoids. And we're going to see some of the issues outlined here, or outlined in the doc here. My bra straps keep falling. Seriously, if someone could send me a video on how to wear a ding apron, I've committed to the bit, but can't do it. All right, so here's what's up. Yeah, you can see here the max speed is disappointing. This is at 100% speed. So this is the first thing that I strongly dislike. Let's just chat about here what the expectation should be and how to get there. I'm gonna make sure I'm in frame, but I want to lean against this wall. Yeah. Chill and chill. Keep chat open. Bum. Okay. So what this calculation needs to be is if there are two neighboring points, we are stating that the time to traverse these 2 points must be 0.3 seconds because they're the nearest two. Now this number came in from my calculation above, but we're going to modify this a little bit to state that if you find your two nearest points, this is our little algorithm, find your two nearest points, assume they go from 0 to 100% of the play range. So previously we used 300 millimeters, the rail length, but that is not realistic. My bullet is left aligned. No. Okay. At 100% max speed. This is the statement that scales or computes our scaling factor. So let's go find our current computation for the scaling factor inside of awesome, not awesome analysis, but awesome PIO. Source, brain. Let's go find our scaling. That is not correct. What did we call it? We called it like spline pattern.h. Sure. LFG. Spline pattern.h and .cpp. And .cpp. Both of them. Right. Okay, so we're gonna load up a spline pattern from file. Given a specific path, assuming it's there, Kate, okay, but we also then need to get our scaling factor. We'll read the cubic spline column of that registry, handle in, yes, and we pulled in some algorithms from the last session for computing the cubic spline y value given time. We just have to get that scaling factor right. So let's go find where we compute the scaling factor. Just picking this up here. Try to, like I said, try to keep everything on stream when I'm doing things. So it's been a couple of days since I've looked at this. Evaluate. Bro, where's our scaling factor? Find segment. Get our Hermite. Evaluate velocity. Character derivative. Sure. So we'll find segment, blah, blah, handle out. Let's just check to see if we do a. Yeah, not quite. Where's our scaling factor, bro? Uh-huh. Total duration. Min dx. Okay. Uh-huh. Min dx is where x is time, to be clear. So it's the x-axis in a xy graph. So we get the total duration, and we're going to loop through all the points to determine if they are closer. So we are assuming an ordered list. By the min distance between 2 points to set the scaling factor. And when we search up min dx, is it simply unused? If it is, that would explain a lot. Yeah, min dx goes unused. That can't be right. I had this issue yesterday or the last time I was streaming, where it simply was not min segment dx. That's unnecessary. It's also uncalled. Yeah, where my indexing was failing. So now I'm concerned that that's the same case here, but if it is not the case, then we will resolve. Okay. Is what it is. Let's go find our evaluate function. All right. Position norm. So at spline time, get position norm, velocity norm with time scale. Talk to me about time scale here, buddy. Setting set speed, right? Percentage time scale. This is heavily related to number 2, or bug number 4, sure. Search total duration. Yikes. Not a fan. Okay. Norm divided by time scale. Interesting. Okay. Not the biggest fan of this approach. Wall DT in seconds. Also, actually not a fan of the fact that this is so deeply nested. But we're gonna do code cleanup later. I gotta keep reminding myself to go MVP vibes. And we are barely vibe coding, half vibe coding. We're gonna solve the problems IRL, and then we ask the robot to type faster than us, but we're not gonna do the opposite. Delicious. Cold coffee. Brain. I gotta wake myself up here. So the max speed calc is wrong, definitely. Min dx we have acquired. So I think the thing is that here in spline pattern, in evaluate, we are getting the normalized that is between 0 and 1 and between 0 and 1 in time and velocity. Let's confirm that. We're going to see if this makes logical sense. We know that all of the points are between 0 and 1. Inside of the array, we are making that assumption, but that is true inside of the data we provided. We have no way to resolve that. Okay, so yes, dx, dy, okay, dt, sure. And we are getting our handle in, handle out slope. Good stuff. We do the Hermite function, which we're just going to go check. This is the vibe. This is just the math we saw on Google. We are going to trust it, but it absolutely does return something that I would anticipate to be between 0 and 1. So let's plan to add a param to this, a Boolean param, to get it to be, excuse me. So tempting, the question then is, do we want the scaling to occur inside of this function or not? Good question. I think that this is only valuable in this context if I don't have any plans for today, like a brunch. Yes, I do have plans today. So in 2 hours, I'm going to jump off. So I am here until 9 a.m. in my local time, meaning the stream is going to be a total of 3 hours. And I'm going for a friend's birthday. So she's essentially like just really into watermelon. We're going to do a watermelon eating contest picnic in the park. That's the vibe. It's going to be a good time. So stick around. We are going to just keep working for the next 2 hours, see how far we can get. Again, going to try to just make sure we're fast about it. So we're going to ask the robot to type faster than us, but not to invent things for us. Let's go. Essentially, the vibe is here we need a Boolean param to compute when, if true, we will not return the normalized value, but instead a scaled value. Default true. And the scaling, this is where we have to be a little tricky. Right. The scaling should be, this is time scaling. Yeah, let's make sure we understand precisely what we're asking for. So the thing that we're asking for max speed, so misspelled calc, let's go. Gotta get my brain on my shoulders. This is the statement. This is what we desire. If I have dx, so we are claiming in code, this is called min dx here. And if I am computing my normalized x, which x is time, so we might as well just, for the sake of conversation, treat it as t. So we're going to say min dt, norm t, sorry, normalized x. Is this correct? Am I thinking through this correctly? Because t is returning as, or getting sent in as. Now let's go to check. Stroke engine uses spline time. Right. Mod duration. Total duration. Interesting. Well, the total duration is 1, my dude. Unless you're scaling total duration by dx. Uh-huh. Yeah. Well, this is hilarious and not good. Not bad, just like not right. Yeah. min dx? Bro. All right. When we draw a pattern, the furthest most x point is 1. Fact. Period. So total duration here is nonsense. Don't get that. We'll have to figure that out. That's from a gentle vibe coding at the end to try to bridge the gap, close the distance, and it is not desirable. Okay, so we have min dt here, and we know that we have a play range. So here, I'm just going to label this chart underscore min dt is the distance between these 2 points. In the y-axis, we are going to assume this is max range or play range. Vertical. Can I rotate text? I cannot. That's cool. Thank you, Tim Cook. Tim Cook, Tim Apple, Tim Cook. So the statement is that the speed because this is unscaled, right? So you just have to do a little bit of math here. So we are assuming that we must be able to traverse max range, which we know, at max speed, which we know. And this in turn will tell us min dt's value. Because right now min dt is a percent of the entire pattern length. Okay, so we must be able to traverse max range, max speed. This is simply max range divided by max speed. Should be the case, is equal to min dt in seconds. And what this tells us is that if min dt was originally 0.01, like 1%, of the entire pattern width, which is only 100%, these are all scaled units, then min dt in seconds might be something like, so for max range, just doing some heuristics here, making sure it makes sense. If it's 220 millimeters and our speed is set as, I think in code, I'm going to check up here because I did this math before. Our max speed is 1,000 millimeters a second, as stated in code. Right, so this becomes 0.220 seconds. Cool. Just doing a little vibe check. Does this make sense to everyone in the audience? Is everyone down for this? I think yes. This does track. This does make sense. And so that means that when we're computing our Hermite for our cubic spline position, given a time t, first, the total duration thing is nonsense. Totally wrong. Doesn't make sense. Because it is not time dependent. It is scalable. Gonna have to fix that. But yes. So our min dt is equal to this in seconds, which means that our scaling factor, so if we're computing our Hermite, just gonna jump back and forth here so we can see this, and then we can prompt our bro based on what we know. Once we have the solution, we just get him to type faster. That's the vibe. All right. Yeah, min dx. Okay. Anyone who's just jumped in, dx is, we're drawing patterns, xy coordinates, where x, the x-axis is time, or time-ish. It is a 0 to 1 unscaled percentage of drawn pattern, and y is 0 to 1, so normalized, unscaled percentage of active play range. We will work on adding everything else in, but when you see dx, that's what we mean. It is not horizontal position. There's some space for confusion here. So we're just confirming here the intent. After load from file, we will evaluate. The evaluation comes in at t in seconds. So is this where we need to start using our scaling factor? Would this come in immediately? I think the thing is total duration, this concept of doing total duration works in as long as we've rescaled so it's in seconds. So right now or milliseconds, because I'm assuming this comes in as milliseconds. So right now we're dumbly, total duration is always 1. Hilarious. But we can do this work without changing anything else in the code if we update total duration such that total duration is equal to the min dt in seconds times what? 1? No. Divided by min dt in percent. Let me make sure that makes sense. So if we're at, again, we're just doing a quick heuristic. So if total duration is 0.220 seconds, and we divide by, we're claiming 0.01, then this would imply that the entire pattern length is, what is that, 22 seconds? Does this track? I think it must track, right? This is the requirement for it to be physically achievable on device, on real hardware, given the assumption that the min distance occurs in the mid time. Like if the two nearest points are the entire rail length, then yes, this is the requirement. It's kind of bonkers, and there's certainly a better approach to this. Kind of using like a work done, distance traveled over time approach, or even looking at the slope between each points. I'm just going to catch this thought, but I don't think we're going to go this way just for now. Like the actual right way to do this is to find the maximum slope between each point and ensuring that the maximum slope is scaled such that it's physically achievable. Uh-huh. Well, now that's such a better idea that it's the only idea that I want to do. So I think we're I think we're gonna do that because it is far superior. It's far superior. The real thing we're trying to do is rescale the pattern to be physically attainable on a real device. The right way to do that, if our cap is max velocity, is definitely not looking at dx, but is looking at the slope between each point. So right here, and just making sure we rescale so the slope is attainable. Oh, dang, why didn't I think of this yesterday or last time? But anyway, this is the play. So we're gonna cap that, move that over, move over here. We're gonna change our pseudocode. So pseudocode now is the statement, find slopes between neighboring points. Therefore, between points. Find the max slope, max ABS slope. This is called, we're gonna call it max slope. Absolute, whatever. Is equal to 1, 2, 3, who knows? It will be in units of percent over percent, so it's going to be a unitless value, which kind of sucks. Yeah, but we will figure that out. Right. So we got this. So we have a max slope, which will be in percents over percent. We're going to say it's like 0.01, just for fun. So we have our heuristic. When would this occur? So if our change was 1, so we're going to say our dy is equal to 1, meaning we're going from 0 to 1. And our dx, we're going to say is equal to, yeah, let's go ahead and do 1% out here. So this means that we have now 100. Okay, so max slope ABS, heuristic 100, there's no units. And we need to rescale such that max slope ABS is physically attainable. And how do we do this? Well, we need to determine our scaling factor for time to get our total duration given max slope. We do know our max speed. We do know our, right. So here's exactly how we solve this. We know that in united terms, we have our max speed, which is 1000 millimeters per second, must be equal to our play range, again, pseudocode vibes, divided by our dt. And I am of the understanding that dt here will be proportional to our scaling factor, but it'll be in units of seconds. Right. Okay, so let's go ahead and do this. We're going to do dt in seconds, dt in seconds. All right. And I'm going to, at some point very soon, introduce primes. If I get into like hypermathy language, then that is a good day for sex toys. But I mean, primes, hey, we're not that far into math. We're doing primes. But, and I don't mean derivatives. I mean like labeling shit with prime because you're double dipping on fucking every single term. Okay. Chill, 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 chill. Mm-hmm. Okay. Vibe check. Heuristic. 1000 millimeters per second is equal to, we're going to say 220 millimeters divided by dt. We do flip. We get back down to dt is equal to, because we use the same numbers, 0.22 seconds. Okay. We find the original percent, so dt in percent is equal to 0.01, which equals 0. So it's equal to 1% equals 0.220 seconds, which means total duration is equal to 22 seconds. Okay, cool. Yeah, system works. And now it's scaled by max slope, which is so much better. So up here, we're going to change this. I'm just going to confirm here, because once we have total duration inside of evaluate, we use evaluate. Right, we find our segment, find the points inside of that segment, inside of our spline, get our handles, get our D's, but I see fast absolute function. Great, where is total duration coming in? I believe that is in play in the Hermite. Let's go check. It is not. Fella, where is your total duration coming from? Oh, it's an implementation, isn't it? Ay, ay, ay. Ay, ay, ay. Right here. Okay, so duration, you do an F mod. And are you normalizing, my dude? Yeah, okay. So I see some normalization based on total duration with an F mod to get the relative spline time in the pattern. Cool. This is totally where bug number 4 is, but that's fine. We'll figure that out. Ay, ay, ay. Have we learned our lesson? No, we have not. Okay, so we assume an ordered list, we have dx equals total duration. We find our min dx, but we actually don't care anymore. So we're going to let the robot type faster than us. So right here, my man, we're going to change to this solution. So we want to, instead of finding the min distance, min distance, find the slopes between neighboring points and find the max absolute slope. For example, the max slope might be 100. Rescale such that max slope absolute is attainable given max speed. Max speed defined here. Should be in config. Ba-bum. For example, 1,000 millimeters per second equals plane range over dt in seconds. Um, this will help us compute our scaling factor. Actual total duration. Because total duration is in percent. For example, max speed is 1,000 millimeters per second divided by plane range, which is in steps right now, which we're gonna have to get. That's fine. Assume plane range is 220 millimeters. So dt is equal to 220 seconds. dt in percent is 1%. Total duration, therefore, is this. Okay, so the important fact that we have to include is note that all patterns are stored with normalized x and normalized y. Okay, let's let this guy cook. Let's go plan the next part. Right, so what is up next? Yes, this is what we're doing. Okay, so I think this is just a note that I left for myself, but yeah, same vibe. We are fixing our max speed calculation so that it is relevant, attainable, good. Speed changes not continuous. Da, da, da. All right, so for the speed changes not continuous part, let's talk about the mathematical issue here again. So if you horizontally scale your function without also horizontally shifting it, the second you change your speed, it registers on device as a jump. So this jump here, I'm going to change this to red. If there was a line, I would draw a line because up line, great, line red and fill, no, line red, good, fill white, sure, I'll take it. Terrible. Fill light gray. That is not going to be good for anyone colorblind. Anyway, moving on here. As we change our speed, we have this situation where the function is horizontally scaled, our speed jumps. So it jumps from the blue point up to the red point, and it is jarring. It is uncomfortable. It will not be even MVP ready. Let's figure out what we need to change and where this issue is occurring. So this issue is, let's think about this for a second. Essentially, we need a horizontal offset. So let's just consider these two functions. Sine x, sine, what is it, 2x, increases our frequency. This gives us the approximate situation we have on screen. And if we assume, like, let's say, x equals, for fun, what was it, pi over, just pi over 2 is 90 degrees, great. We're just going to state x equals pi over 2. Then the situation is that this would be equal to, then sine x is 1, confirming. Am I wrong? Is my brain wrong right now? No. And this should be, what, square root 2 over 2, if I'm right. Am I wrong? Well, I'm imagining this circle, but I think it's square root 2 over 2. Or 2 over square root 2. Let's go check. Let's go check my basic basic trig. Sine 2x, baby. At x equals pi over 2. Yo. Nope, nope, nope. Uh-huh. Oh, at pi. No, is this what I wanted? Or do I want to divide by 2? Bro, that's what I get. That's what I get for not having coffee this morning. I say that as I'm surrounded by my empty coffee cup. Just gonna draw these things. When in doubt, just take your time. Double checking. We got our sine x. Sine x over 2, baby. Let's go. Make sure my brain's on. Okay, great. Increases frequency as desired. And then at x equals pi over 2. Let's figure it out. Yep, okay. So this is identical to square root 2 over 2. Great. 1, perfect. This is the intent. Good to go. Brain is on. Brain is effective. Brain is good brain. Thank you, brain. There we are. So the intention, the important part here is that we are jumping. So let's just grab our graph here. We can talk about it in detail. Ba-bum, ba-bum. Does anyone use this tool anymore? Like, has Wolfram Alpha died? I used to use Mathematica and Wolfram Alpha every single day. I mean, like literally every single day of my physics degree. And then, yeah, I guess no one else ever used it. My lab used it at the time when I was doing physics. I just no one else, just never saw it again. Sounds like I'm being sentimental, but I kind of am. Anyway, right here, boom, 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 boom. You can see the jump. So the thing that we need to do is we need to make sure that we horizontally move the function such that it's at an identical point. In the case where this is, yeah, that's an interesting problem to solve. Okay, so for an arbitrary function, how much do we have to shift it left or right such that during a speed change, it has an identical continuous value? That, that's an interesting question. Let's just write it out. Okay. So first, for the sine wave, how much do I have to shift function left? Does sine x over 2 have to move left such that at x equals, we'll assume instantaneous time change, such that at x equals pi over 2, whatever, at any given x, but the function of sine x over 2 is equal to sine x at that point. Okay. I mean, this is relatively easy to figure out. The question is, where do we want the addition? So I think the thing that must occur, and I'm confident about this, is that we will have sine x plus dx. We have so many dx's here. Disregard them. Crazy. At sine x when x equals pi over 2. This is an interesting problem. We'll just arc sine everything. I mean, it becomes very easy until we consider the general case, but I think it'll be fine. Actually, it looks like the math is going to just be pretty chill. I'm just going to write it all out. I mean, it's pretty obvious at this point where it's going, but yeah, okay. So dx is equal to x. The question is this the general case? So in the general case, do I need to shift my function to the right by the current value x? And just for proof sake, we're just going to like pop this over here. We're going to say we're going to add in, we only care about the evaluation point pi over 2 for the purposes of this discussion. Let's go ship it. And yeah, we can see it is in fact the case that when we shift the function, we maintain our new frequency in the green line here, but we have now assured that the sine wave function is at the exact same point. The question is, does this generalize? Does this generalize? to an arbitrary C2 continuous function. Let's check. What is a safe way to check here? We could get all proofy, but I don't think we will. If we always offset by x, yes. Let's just like, again, heuristic. I think this is going to be the case. Going purely from heuristics. Like, just, again, I'm not even going to go in detail. We're just going to go vibe. Just consider a function g, where g is C2 continuous. Let's also make the assumption that there is an inverse function of g. Given that there's an inverse function of g, then it's always the case that dx is equal to x if the scaling factor is 2. Okay, so we're going to have to change this here. So if the existing scaling factor is, let's go z. A little messy. That's fine. But given that there is an inverse function of g, which we assume, let's go cap g just for the hell of it, then the offset to maintain continuity during speed change is, right, yeah, sorry, x over s sorry, just being thorough to make it clear. We assume the inverse exists, minus x. Okay, this is our general approach for the arbitrary functions that we are using. Let's get there. When we get there, yes, 1 over s minus 1, yeah, is equal to x times 1 over s minus 1. We can clean that up a little bit more by dividing by s instead, so let's just do that. So we have it, so times s times s times s minus 1. All right, yeah, I'm cool with that. Kind of makes sense. If our scaling factor is 1, dx is 0, yeah, okay. I mean, it's pretty chill. That works. Okay, let's go check our vibe code here. Well, but for real, let's go actually make sure that we confirm everything makes sense. Max slope absolute, because we don't really care about the minimum segment dx, duration seconds. Max speed in millimeters per second. I mean, you're kind of isolating yourself, and that's fine, but is what it is. Okay. So total duration will be determined at runtime when the file is read. Play range in millimeters, max speed in millimeters, speed in hertz. Cycle period. Bro. Okay, from a code design perspective, I understand it's trying to decouple the concept that I passed to it called spline pattern. It's trying to decouple that from the awesome code. But bish, I'm making a library. Couple it. Get it coupled. You know what I mean? Move this play code, this computation in. What is duration seconds getting computed for on every loop? That's insane. Ay. All right, MVP. So let's go. We're going to try to resolve problems. We don't hate what it's done. We just dislike it, and it needs cleanup off camera. Let's try to get some fun. We're trying to get you guys a fun feature. We're gonna not stress too much. All right, time check. I got an hour and a half today remaining. Nearly there. Okay, we're just gonna reflash machine. We'll hide this. We'll hide this. We'll give you the logs. She's flashing. Ba-ba-bum. Yeah, we're gonna see what happens. Wish me luck. If you're out there, I got six wonderful folks in chat right now. Thank you so much for hanging out. I know it's extremely late in Europe, late in the evening in North America, start of your weekend. Yeah, just happy you're here. Thank you so much. All right, we are homed. Going into stroke engine, decreasing speed. Okay, it's just simple stroke, simple pen. Let's switch the pattern. So double clicking. I'm going to go down to the pattern called test pattern, which is a trapezoid. All right, we're starting to see some of that choppiness. Ooh, it's disappointing. That, oh, that's so disappointing. Wow, that's bad. Uh-huh. So it's only consuming 50% the range, which I had set in as a limit last time. I'm gonna go through. So we have the choppiness that we were concerned about here occurring. Right here. I'm providing a trapezoidal pattern. I'm asking it to do trapezoidal motion. And it is, but because we're sending so many commands, it's getting like a little overwhelmed and just going chop chop chop, which we dislike. Okay. So we're finding our key file. Okay, get out of my hair. All right, let's go. Yes, key file is fine. Let's go. Just gonna take a look here. This is driving me insane, but we're gonna accept it. Okay, we have our pattern ID. Is this a nested loop? That's crazy, dude. So not into that. Oh my God, I'm so not into that nested loop. That's insane. Ah, that's terrible. Oh my God. Oh my God. Oh, that hurts so bad. Jesus Christ. Sorry. I just a nightmare. I I hate looking at it, but we're going to deal with it in a second. MVP mode, man. MVP mode. Okay. So we are disappointed in our play range. What is up? Load for file. Start here. Play range in millimeters is stroke steps. That's from calibration, measured stroke steps, max speed in millimeters per second. It's here. Max speed hertz. Yeah, this is our operator. Okay. Max acceleration. Sure. Duration, seconds, spline duration is total duration. What is output cycle period here? Let's go figure out what this fucking thing did. Not a fan. Or we're just gonna go manual fix. So what we get max slope. Right, so this is wrong. Yeah, the max slope is in normalized units. Let's go off. Yo, this is smelly code, man. We got to get in here. But polish will happen off screen. I cannot just leave you while I go off on wild goose chase to clean up my code. So we are going to, in fact, very disappointed in our robot. Yes, we have our dx, we have our slope, absolute. Yes. This is previous point, next point. Okay, down, max slope, great. So given our max slope, we also need to know our slope dx at max slope. Okay. Because the thing that's important is, critically, the total duration from our actual brain, human brain, is here. Right, so if dx in percent is 1%, dx at max slope, we have our max speed, so total duration, let's just review the calc. So total duration is equal to, in fact, I'm so annoyed, so deeply annoyed at this whole situation that I'm so tempted to just undo it. In fact, I am going to undo it. See ya, buddy. Yeah, that's chaos. It's chaos mode. We will keep this nuked. Fuck that shit. Max up slope. We're just gonna float this locally for a second, just for the convenience. Dx at max slope. So therefore, total duration is equal to, this is dt at percent, right, is equal to dx at max slope as a percent. Come on, brain. You're just here thinking about too many things, leveraging too many active threads. So we're going to drink a little water. Ugh. Look at that motion control. Disappointing. Disappointing. But we'll fix it. We'll fix it. No problem. Okay. So total duration, which we then later use for calculating position, and it should be a simple change, is such that given play range, can we do this on init? This is a load from file. Yes, we should be able to do this on init. So total duration. That is not correct. Thank you, autocomplete. Thank God. Today, I'm just not in the mood. Just not in the mood for the bots. Or they're not in the mood for me. Maybe they're getting worse. I do know that I wish I had another gigantic coffee. But I don't. Sad. If one of you, like, there's 7 people here, if one person flies over and brings me a coffee, I would be so happy. Also, welcome. Can't see the names at the moment, but I hope you're having a good day. Hope if you're up late, then I hope you get a lot of sleep tonight, whether it's at 3 a.m. or whatnot. And if you are just waking up or anything like that, I hope you have an amazing weekend. Beautiful Saturday morning here on the Asiatic coast. Is that accurate to say? Don't know. But facility. Okay. Water acquired, brain activate. We have our min percent, we have our max slope. These are all unitless values. We do know our max speed. So our max speed is such that right here, we have a unitless value. It's attainable. have our max speed, we have our play range, we have our dt in seconds. So we make the assumption that max slope absolute is equal to our max speed. We never actually need to store or save the information about max slope. It is not required. All that is required is the dx at max slope, so that we can assume that it occurs, because we have dx in percent, assume that it occurs with max play range. So the things that we need to add here would be load profile. Essentially, we need a better constructor. That's fine, because the constructor should do this shit. But we're just gonna push it. Okay, so play range in millimeters, max speed per second in millimeters. Let's go change our .h and put a to-do to just improve the constructor, because that is getting pretty smelly. Or maybe that's the kind of thing I trust the AI with. But essentially, this should always occur. Should always successfully load from file and make these computations. That said, moving on. Moving forward, right, we have a section for to-dos. God, so embarrassing in retrospect to go through these notes, but our to-do section is Vaporeon, because that day I had a conversation with my roommates about which Pokemon are conceived by the public to be the most fuckable. So sorry. And Vaporeon won that conversation. So the to-do section, we are adding in, we must improve the constructor of spline pattern. We must, it sounds crazy, we must couple the code between spline pattern and awesome. Is that required? No, it is not. Will it slightly improve our quality of life? Yes. So we're not doing all these calculations. I really want inside of the stroke engine.cpp file. The target here is we're just running spline.tick, which returns like your current velocity and speed. Sorry, velocity and position target. That would be awesome. Right now it's too complex, so fragile. Yeah, testable, very testable, but too fragile. So these are in our to-do. We're not going to deal with them today. We're just going to go back to our calculation here. Robot totally failed us, so we're hand coding this. And we have our solution, so it's not even a problem. The only issue, again, just AJ's coffee. So here we go, here we go. Don't need to save this. We only care about reverse solving for this. We're just going to go messy code first. We're going to copy our code that we wrote on the left, dx at max slope as a percent. Right, so we have our max speed in millimeters per second is equal to, just copying out pseudocode right now, where you will figure that out, is equal to play range over dx at max slope seconds, or we probably want milliseconds. Let's go ahead and do seconds. It's fine, because the speed is in max millimeters per second, which means that we multiply, we divide, we have this flow at dx max speed slope in seconds is play range millimeters divided by max speed per second. Okay, good stuff. Okay, perf, kill, good stuff. That means that if we have our slope in seconds, then our total duration, right, our dt in percent, and our dt in seconds gives us a total duration as follows. That is dx max slope seconds divided by percent. So if this is 1%, then yeah, just like this. So if it's 1%, that would correspond in this context, in this heuristic, to 0.22 seconds, which is a 22-second total duration. Because we mod everything, we're providing time in milliseconds, though. So we should double check this. God, the implementation code here. Oof, oof, am I ever. Am I ever. The second we clear like a reasonable MVP and we start targeting delivery for folks, I'm gonna clean the fuck out of this. Just drives me crazy. Drives me insane. Timescale. Yikes, 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 yikes. Yikes, 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 yikes. Oh my gosh. So unnecessary. Why is this occurring outside of the oh, get out of here, man. Couple the code. Why you don't gotta decouple like this? This is too safe. Ay, 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 ay. Tick rate hurts. Sure, sure, sure. Should be 10. But what I'm seeking instead of our doubly nested while loops, insane. No, thank you. Ay, 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 ay. Not a fan, my friends. Fact that we call load from file manually. My gosh. Stroke steps. And we need to convert this. Identifier is empty. Measured stroke millimeters and yeah, okay. Then we will couple things as needed. This is already in millimeters per second. This is already in measured stroke millimeters. Good. Double checking. What I'm curious about is how time is getting passed forward. I think it's getting passed forward in milliseconds, but our scaling is in seconds. So we're going to take a look at that. Evaluate at spline time. This is 8%. But fmod here, total duration, spline time. Is anyone multiplying by 1,000 dt in seconds divided by tick hertz time scale? Yeah, what's hertz value? Okay, you are dividing by 1,000. Do I believe you're in seconds? I don't think I believe you're in seconds, man. The number of ticks. Oh, yeah, in hertz. Okay, tick rate hertz. Okay, chill, chill. I'm down. I'm down. It's in seconds. Let's go. Let's see what happens. We're hoping it's kind of like watching something in the Colosseum, you know? You kind of you kind of hope if you're in the Colosseum in ancient Rome to see someone die, so to speak. And right now, I kind of hope people are watching in the gentle desire that they watch this awesome slam into the heart stop, but it goes chaotic. I do. I would watch for that reason. I want some chaos. We're optimists here. We're optimists. All right, get out of here, AI. You did nothing. You did nothing for us. Oh, baby. Oh, yeah. All right, ETA. I got 1 hour, 10 minutes. We're going to see how far we can get. If we're in a somewhat stable state. Let me give you some logs. Sorry about that. If we're in a stable state, I will push code. And then we'll consider if we're going to call the feature a wrap, and I will do the polish off screen to deliver it, or if you want to like hang for the polish, that's chill too. But it's close, man. It's close. All right, let's go. So here we are. I'm in stroke engine, reduce my speed, double. I'm gonna go down to test pattern. Okay, it does look better, but again, it's only 50%. Okay, we still have the, or what do we got? We got choppiness, which we just like. We have low maximum speed. We have significantly reduced play range. We have all of the problems. Yeah, literally every problem is present right now. Hmm. Yeah, they're all here. All the friends. No crash. No crash into the hard stop. So that's nice. Okay. Let's think about this. Why is that occurring? Mm-hmm. Okay. Zeroed out. Sure, sure, sure. DT in seconds. Better be afloat. Of course it is. Just checking to see if this is a casting issue. So total duration. Let's check our logs. Let's go dig in. What do we compute here? Time in stroke, time out of stroke, patterns. Connected to MQTT. Thank you. Tell you what, don't care, bro. All right, connect to Wi-Fi, connect to MQTT. Yeah, okay. We need more logs. That's what's up. This, sure, man. Would I trust this? What level is this? Is info level? I thought it was debug level. Why am I not receiving this? It's my tag. Yeah, it's spline pattern. Let's check logs. Okay, 3 points. Max slope is 2. Yes. Duration's 1. You fool. Of course duration's 1. What is getting read? What is getting received? I want to see a few things. So I want to see our scaling factor. So total duration. Does it make sense, first off, that total duration would be 2? Loaded. Duration is 0.36 seconds. That can't be right. Duration is 1? That can't be right. Okay, let's just log all this. Uh, um, okay, and then once it's running, I want to see. Let's go over here. Again, this is why I dislike that it's all decoupled the way they did it. And so we're going to fix, but position norm, let's just go ahead and do target position. That's all I care about. Yeah, I get it. You got verbose here. Let's go. Let's run that again. Let's see what's up. It's going to be a little noisy. I'll figure it out. Hi. Yeah. Debugging without coffee. Man, is what it is. If anyone's in the mood, or if anyone's just like up and around, sitting by their awesome, you're welcome to join me. Just ping me in chat and I will send you the code. Or I'll like push the code up to the branch. You can flash it. You take a look together. Definitely down. I'm gonna add some more people in stream as we go. Like, I'm gonna keep going every Saturday. Change the time around for more distribution globally. Just make it a little bit more convenient for everybody else, not just the North Americans. And As I do that, I'll invite different developers from the KM community to pop into stream, maybe share stream with me for a couple hours. Be pretty sick. All right. Okay, let's take a look. So first off, crash avoidance. Oh, wrong pattern. Okay. Let's go. Okay, we're just gonna kill this so I can take a look. So max slope is 2. dx at max slope percent, 50%. dx at max slope seconds is definitely wrong, right? Let's confirm this. dx at max slope seconds. No, okay. All right, I see. Let's confirm this. That is the time to traverse our entire play range at the maximum speed. What I needed to have also written to get the information to make sure my math was correct, my simple division was correct, was the play range. So let's see if I, millimeters, did I write this down? Play range in millimeters is 179.1 millimeters. Okay. That does seem to be present on the previous logs. So we're going to look for play range. Previous logs, sure, not current logs. Crazy, man. Crazy. We have 5 people and already 2 spammers. That's crazy, dude. So special. Oh my God. Unexpected, just truthfully. Just totally unexpected. Got these lovely 6 people hanging out, and one of them must just be like a bot jumping through every possible channel. Who knows? All right. I mean, at crazy low speed, maybe this makes sense. Let's take a look at the target positions provided. So I want to do a little bit of a text extraction here. So this is the good time for a little tooling. Make a script to extract this code and plot, and then like a Jupyter notebook. Jupyter, is it too much? Yeah, and plot it, baby. Let's go. Yeah, I know there's CLI tools for live plotting data from an ESP32. I'll have to figure that out. What is going wrong? That is my question. Play range millimeters. So I recall I put in a safety to set us to 50% of the play range. But even then, I'm super disappointed. Yeah, super disappointed in how it's moving, what it's doing. Okay, let's go. Yeah, some stuff now. Thank you. All right. Plot run, T monitor. Let's catch some data. Huh. Okay. Here we go. Catch it to here. Boom, boom, ba bum, ba bum. Give it to the bot. Up G. Crash. Yeah, buddy. Just fly the dang thing. I'm ruining the environment because I don't want to use matplotlib. Oh my god. Yeah, I know, I know. I'm being so bad. Yes, yes. Just plot it, buddy. Okay, let's take a look. Yeah, what is going on here? So the spline T position norm. So it looks like all of our calculations kind of suck. Because target, like if we're being honest, it seems like it's correctly computing or correctly performing all of the requests. And it's just bad. So the situation almost certainly is that, well, what's wrong here? Is our Hermite wrong? Is it wrong that we're doing Fmod? Are the units wrong? These are all the questions that I have. So let's go back to the drawing board a little bit because very, very, very clear target steps. Like that's crazy, dude. First off, jumping, jumping, which it's doing correctly. And it's receiving position in millimeters and spline T. I mean, the fact that spline T is jumping around is the problem, is the issue. So spline T needs to be a value between 0 and 1. And then it restarts because this is a cyclical pattern. The fact that velocity, and also what is this jumping? That is interesting. Well, let's go. We do know where the issue lies. The issue lies in our computation of spline time, spline T, which is already chaotic and unnecessary. But let's go check. So we have our DT scaling, blah, blah, blah. We were hoping that by doing duration, total duration, we have float mod float. We're doing spline time, which is using the tick interval. Yeah, it's determining the number of ticks which have occurred since the start. Interesting, which is going to be, do I trust this? Let's just go simpler. Let's go dumb for a sec. Original tick. Why are we doing ticks though? Just go float. Sorry, like, what is it? Big old int. It's called long. Thank you. Long start time equals millis. We're just going to the classics. Create this tick stuff, bro. All right, here's our start time. We are going to state, yeah, sure, last log time. Okay. Well, DT_sec is millis minus start time divided by 1000.f. Last log time, no. time scale, spline time. Yeah, okay, this is definitely part of the bug. We accept it. The bug is still bug 4, as noted, where we have this misalignment of two functions, which is here. We are going to temporarily accept it. We do have a solution for that. We've, under the assumption that there is an inverse function to g, where g is a spline, then we know that our horizontal offset of x must be x times the scaling factor on the original x over here, -1. Just thinking about, do I care about another kind of offset? No, this is satisfactory. We're okay. Cool. We will solve that later. So we have wall dt in seconds. Not sure what the naming convention is. We will change that. Millis minus this divided by 1,000 brings us into seconds. So spline time is seconds, but not dt, divided by time scale, where duration is, we get spline time is equal to, right, spline time is equal to this, divided by time scale. Position norm is spline time. All right, let's give that a shot. I think the thing is that the robot here, oh gosh, what is he doing even? I don't want to justify his actions. When we left last session, again, we wanted to like close the loop on a couple of thoughts. So we allowed, like, built out a very thorough structure and request. We allowed the AI to go rogue, and my God, did it go rogue. It went bad. And I'm digging into the code now, and I'm quite disappointed, to be frank. Hi. Mhm. All right, timeline here. I got 52 minutes. Objective is to get something workable that I can hand to all of you folks, so you can just have a bit of fun, explore, try it out. It's definitely not play ready, but in those 52 minutes, we're going to try to resolve the major two bugs. Those major two bugs being discontinuity on speed change and the pattern, simple pattern replay. Oh, but the code smells so bad right now. I'll have to fix that up. All right, stroke engine going in, speed down to 0, double press, moves us into test pattern loaded from memory. So I'm still disappointed with play range, but it's smoother. I feel like we're definitely getting a little Nyquist frequency garbage here. But let's pause that. Well, I'll let it run. Let's go look at our plot. Let's get another plot going. Okay, say path to terminal location. There's a path? Now let's go. So I'm just gonna go into Scratch here. I have a Scratch directory almost everywhere. I'm sure I do. Perhaps root level, Scratch. Terminal.txt, paste. Let's go. Let's run this command. This is sure Python 3, blah, blah, blah. What? No such file or directory. What do you mean? What do you mean? Oh, oops. No spine control data found in file. That is false. Boom. Boom. Yeah. So now the question is, first off, have we fixed our computation of time? For computation of time, it looks smooth. Then we're satisfied. If the computation of time is still a problem, then hey, life is simple. We just have to figure out why. Why is it a problem? They should have been there in the original rejects. Don't make her line number. Yeah, yeah, bro. Mm-hmm. Give me that plot, baby. Is this latest? Not sure. Snook it. Come on, buddy. This one. Yeah, this is right. All right, let's consider. So our time computation is not exceeding 0.3. So spline time before it, is this spline time in seconds? This is very interesting data. It's very interesting data. What is this telling me? Spline time is in seconds. Let's get you out of here. Let's clear the dash. Let's start thinking. Let's clear our brain out too. Velocity, interesting. Okay. So target speed, again, with the shape, the target in steps should be a trapezoid. That's the command we've provided. So our spline time in seconds. What is this information telling me? It is telling me that I am moving at my max speed here. And I am hitting 3 points. And those 3 points are not the 3 points requested. Very much feels Nyquisty. Target in steps. I mean, if I reduce the speed, I'm not exactly hitting full range either in steps. Right? Like, we're not taking into account at all any account whatsoever of depth. But I mean, I'm just going to crank them just in case. Sensation, we're going to crank up, depth, we're going to crank up, and stroke, we're going to crank up. It should have no impact because that code is not considering it yet. It does not. It's okay. Ruled out. Is our time computation the problem? It seems to be necessarily the problem. Yeah, like definitely, right? Because we have very clean time readouts. And then all of a sudden, even our time computation seems incorrect. Is it insane to increase our frequency? Like super likely that's not a good idea. If we went to 20 hertz or something. Let's just say fuck it and jump up to 20 hertz and see what happens to see if we can get rid of some of this right here. I'm calling it Nyquist. It's definitely Nyquist-y, at the very least. Huh. Time computation. Second, let's get our time computation normalized as well. Let's print that out, make sure it makes sense. Stroke engine failed, blah, blah, blah. Evaluate. Where's this log? Spline time. Food. Spline percent. Target T. Yeah, okay. Let's just confirm position of sets position norm. I actually meant time norm, but thank you. So time norm would be, guy tries so hard. He tries so hard. Hum, 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 hum. Milliseconds for time. Spline time divided by time scale. This is a function of speed, so that we're going faster through it. We're at 10 friggin' hertz. Why is it jumping around so dang quick? Because we're making the assumption that at max speed, I can traverse the distance between two neighboring points. No, we're making the statement we will find the max slope on this pattern. We will make sure that max slope is physically achievable given the parameters you provided. That's the statement that we make. So when it is choosing 3 points, that is that an accurate expectation? All right, let's find out what happens. I want to see. Let's just double the hertz. Let's double the frequency that we're running this. Again, doubly nested while loop. Disgusting, but we will clean up later. Today is about fucking around and finding out. So tick interval, milliseconds. This is what we're delaying with. Let's go with 50, dude. Let's just see what's going on. We're risking problem number 2, which is that we spam the motor, but I don't think we're close to that yet. So we're not going to worry about it. Okay, I'll run. Let's go. I just want to see. Let's see if our time calculations come out a little bit better, a little cleaner. Yeah, and then once our time calculations are clean, we'll go into the rest of it. Because if we go back to this plot, this is disappointing. This was good. We have to do some validation to confirm that like these time steps are as expected. This was bad, obviously. Position norm was bad. So very clearly, something's going on here. This will be our next step in the investigation because position norm, it should be trapezoidal. That is the requested pattern that we are going up, down, in, out, trapezoid. How's my battery? 18%. Mwah. It's gonna be a close one. Where's my terminals, baby? Uh-huh. CD software, thank you. Trapezoid, baby. All right, so we know that there's going to be a problem. There's a problem in time, which is appearing elsewhere. That is order 1. Order 2, there is a problem in the position norm calculation because it is supposed to be trapezoidal, and yet the time modulus does not permit it to be. So this could be an issue with our total duration calculation. And the simplest test for this would be to just arbitrarily and simply for the sake of hypothesis testing, to double our total duration to see if we get more of this trapezoidal pattern as expected. The fact that it's going da 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 and then reset slam down is not good. It indicates a problem there. Same with velocity. This is an instantaneous velocity change, which we don't like for obvious reasons. Sure, somebody would love instantaneous velocity and target steps. I mean, it's the same as position relative. Okay, so let's go. Going into stroke engine, speed down, speed up. That's simple plan, chill. I also noticed we load the pattern here. Okay, let's take a look. Let's get that terminal content. Let's get some fast content. Let's kill it. Okay, let's put this in here. Boom, boom. Let's run our analysis, which will almost definitely crash. Let's chill. Let's go here. Da, 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 da. Yeah. The thing is, my little friend, we've changed the structure. Mhm. I mean, it looks better, but certainly not good yet. Hmm. Mm-hmm. We'll time it. New format. 28 seconds. Blah blah blah. Let's go. Let's run it. Okay. Let's take a look. The only change we made, to be clear, is we changed the frequency to attempt to the hertz, like the operating frequency, to attempt to get rid of some Nyquist patterns here. We are still seeing it. Yeah, certainly it has improved slightly, but no, it's still present, which we dislike. And we're gonna accept it. It does not seem that we're stalling out the motor. So let's do our second hypothesis test. So hypothesis test 2 is that our total duration calculation is wrong. To test this hypothesis, we're just going to double the duration to see if our position norm becomes our trapezoid. Because right now, this is not trapezoidal at low speeds. That is highly evident. So let's do total duration. Yeah, compute it here, which just returns total duration. Again, this is totally arbitrary. And for those with popcorn, will likely result in a slam into the hard stop. So here we go. Let's go. Let's go. Let's go. Let's get this thing slamming into the hard stop. Let's go. PIO run, baby. Yeah, because we're norming by total duration or modding by total duration. It's intended to be a cyclical function. We should figure out why our calculation for the total duration would be anything less than the entire full correct range. That is unclear to me. Because we take the amount of seconds that it takes to traverse our play range, and if it's 50% of the total play range, then we divide by that, meaning that it's multiplication by 2, so our total duration calculation should be correct. Again, this times 2 factor that I've just added is exclusively for testing. If we see a crash into the hard stop and we see better data, then we know we're on track. Okay, so let's hope for fireworks. I think one day what I'm going to do, because I haven't seen anyone do this test, I'm just going to get my awesome and a couple of spare linear rails. I'm just going to really stress test this thing. I want to put so much force on it that it breaks. I want to see where that limit is. If that's interesting to you, let me know. But it's very interesting to me. Okay, I'm going to go down into our test pattern. Let's go, baby. Let's go. So total duration multiplied by 2 is very, very interesting. Whoa. What is this? What is going on here? That's crazy. Cycle index. What is going on here? Oh, that's the wrong pattern, dude. That's the wrong pattern. Oh, that's the deeper pattern. And my depth is set to nothing. So yeah, of course. That was totally expected behavior if you're in the wrong pattern. Not sure how I selected that one. So we're gonna check eventually if there's just like a bug. All right. Good sign. Good sign. To be clear, the good sign is that it seems we're not crashing into the hard stop. And at slow speeds, it looks like we're getting more of that trapezoid, but definitely at a reduced play range. Okay, let's crash, let's plot. Let's go, baby. For those of you multitasking, we are ready for our next plot. We are coming up to it pretty soon. We'll let you know when it's beautiful. Okay, we'll take that. We will go into terminal.txt, nuke, paste, and analyze. Let's go. Save this spline plot. Let's just confirm that it's not the correct one. Let's open this one. Okay. We're still not reaching. Huh. It's very interesting to me. So position norm is supposed to be replaying a trapezoid, and it's so far from doing that. It is so definitely not. We're just still seeing these staggered jumps inside of time computation, which is insane. So let's go. What am I curious about? I'm curious about so many things. But first, we simply are not computing our position norm correctly. Period. Full stop. Nothing else to it. It looks like we're still in segment 1 and not retrieving segment 2. That's my concern. Yeah. And why is it curved? What is this? What is that? What's going on there, man? All right. So let's go back to code. Let's figure this out. Find segment, I'm guessing, is failing. Total duration is messy. And multiplying by 2 did not have any positive or negative impact, and in fact, just continued the same issue, implying that the problem is actually inside of evaluate, where evaluate takes a t, time t. Is this normalized? On input, which by the way is bad, it should be a tick, but yes, spline time. This is in seconds. So no, we are passing forward the time in seconds, which let's confirm time scale is settings divided by speeds. This is a percent. This is in seconds. So we need this to be a percent of total duration. Can I confirm that for myself? Does wall dt seconds divided by time scale also need to be divided by the total duration? So that it becomes a percent. I think that is the case. We're going to do something messy. Duration. It is assumed that the data is normalized. It is assumed that evaluate has no physical information about this curve, and that it only ranges between 0 and 1. These are the statements. That is my case, Your Honor. I am at 8% battery. All right, let's go. I think strictly that's it. We're gonna find out quick, very quick. I'm also gonna just see if I can charge off this, which is way too low wattage, but then it gives me at least a couple more minutes to hang out with you guys. LFG, good luck. I see juice. Battery's not charging, no doubt. There's no doubt in my mind that battery's not charging. Okay. 30 minutes left. Yeah. All right. Current implementation is a little bit of a mess. It's okay. Is the case. So we'll learn. We'll learn. All right, let's take a look. So we're homing. Let me give you full logs here so you can take a look here as well. It's going to be a bit messy. Okay, we are going down to stroke engine. We are doing speed 0, press. I'm going down to test pattern, which is loaded now. And let's increase our speed. I mean, I see something different. It's supposed to be over the entire play range. So I'm quite interested by this. Okay, same thing. Let's go through. T is equal to blah, blah, blah. So T is equal to 1. I'm so interested. What is going on? We're gonna have to dig in. We're gonna have to dig into this. So catch all these logs. Let's go up here. Let's go into I'll find you, pal. Hello. Get out of here. Terminal.txt, nuke placed. Python 3. Let's go. What do we got? Why? Why are we not progressing correctly? I think perhaps our calculation is wrong. All right, first off, time is not moving as I expected. So spline t should be going from 0 to 1 continuously and strictly positively. What the fuck? Huh. Because you're speed scaling. Is that right? You're speed scaling. I understand. I see what you're doing. So this is where we would have to start using our scaling factor as an offset. We can do that. But that's what these bumps are. That's the discontinuity. When I hold speed steady, we still are not traversing as expected. You see this? I'm feeding it. Let's make sure I'm not wrong here. So inside of data patterns, we're loading this pattern. At x equals 0.5, y is equal to 1. At x equals 1, y is equal to 0. That is a friggin' trapezoid, dude. That means, let's check our period here. So this is 0 to 1. I think that there's a chance. So if we look at this, this is our period 0 to 1 right here. And we see 2 spikes occurring, which is potentially implying to me that we are completing the first portion of the trapezoid, albeit with some bumps and lumps, which we will correct. And then we complete a second period of the trapezoid. In that window, we also complete a third. Okay, fuck. That does not align with my expectation. I was hoping. Yeah. I mean, it simply does look like we are computing these things correctly. Sorry, I'll be more clear. It does look like position norm is showing the same data errors, like these spikes, as we see down here. Let's correct those data errors in time because that's a very simple thing to resolve. Okay, so spline time, your time scaling. We have our solution over here where if we are stating that Oh, shit. Yeah, dx divided by s1. Right, this one is, God. No, we're gonna do it relative to, no, it has to be relative to previous, doesn't it? Let's go. This gets messy. dx1 plus dx0 divided by s0. All right, these are the scaling factor requirements. So under the assumption that we have two functions, both continuous with an inverse, then the statement is dx1, which is unknown. We'll assume dx0 is known. This is the case here. Messier. It's definitely messier. But we will accept it. This is all divided by s1, so we will just multiply by s1. So square 1 times all this. Right, and then minus x. So x is known. dx0 is known as the previous offset. This is the scaling factor in order to get the continuous function. That's fine. Okay, so current spline time, long current spline time. I don't want to. Let's go float. Current spline time is 0. It's going to be a positive float between 0 and 1, where it is our percent. We're going to do total duration, gross. Something's going wrong there. We'll figure that out. Okay. So time scale. Yeah, last log. Here's what I want to do. I dislike the time scale as being discontinuous. It is being discontinuous because it is being modulated by speed. These are the facts. So if I want to correct that, I'm going to have to implement this, which is fine. Are we even ready for that? I don't think so, because we are still simply not replaying a cubic spline correctly. We are not given a value between 0 and 1, getting the number that I expect. Why is this the case? Let's go into evaluate and just walk through. Again, we're going to go heuristic mode here. Let's pull this code across and out of this section. We're going to go here, gross. When in doubt, use your dang brain, right? So let's get a screenshot of this code, pull it in, and figure out what the hell's going on. Just heuristics. Just choose some numbers. Choose some numbers. Compute. See what maths, what doesn't. Clipboard, baby. Capture. All right. Got one. Let's go to our Hermite. Let's validate these things. It's going to be pretty damn simple, too, because like our function that we're starting with is easy. Is very easy. So we're going to look at time equals 0. Time equals 0. We expect evaluate to return 0. At time equals 0.5, we expect evaluate to return 1. At time equals 1, we expect evaluate to return 0. These are the statements inside of our file. So inside of our pattern.json file, which we created, that encodes information for a trapezoid. This is the desire. Let's just walk through. We know our handles are all 0, so we're not going to worry about it too much. It's a rigid trapezoid, no curves. We can even do 0.25 if we wanted. But let's just go through these ones. I will state that 0.25, the time equals 0.25. We expect the following thing. We expect evaluate to give us 0.5. Trapezoid, baby. Easy math. All right. There could be an issue in fine segment. Let's walk through it step by step. We have our points. It's not size 1. We're good to go. Total duration is greater than 0. We are F modding by total duration. Is this already the issue? Because we're F modding by total duration. Is this already the problem? Because we F mod outside. Bro. Huh. Let's confirm that is not stepping on the toes of anything else. So spline time, we're passing as a percent. Total duration, realistically, we're never going to exceed. Yes, it's now anti-pattern. Yes, it's messy. Let's fucking crush it. It's irrelevant now because we are assuming that a percent comes in. Code cleanup. This is very smelly. This is very smelly code, but we're just POC, proof of concept. That is the ambition. That's our goal. That's our target. Find segment. Let's go kick in. So at time equals 0. Not the case. Point size. Okay. So find segment at time equals 0. Right, because x in our point structure is time. We should normalize everywhere. Let's put that in our to-do. Code cleanup. Up here with Vaporeon. Hello, baby. Time. Normalize variable names so that x and time are both time. But for now, we don't care. For now, you'll just remember that x and time are the same. So in here, if time is less than, okay, so let's read through. We have our size, we have our points, we get for every point dot x. We're going to step forward. Right. So if time is less than, then we return the index of the previous. Okay, yes, this makes sense. So in the case where we have provided these segments, which we have provided, precisely, in fact, let me find it. No, I have this photo. When we precisely provide these segments, the statement is, if x is 0, then we loop through, we're looking for the index of the segment to make sure. Right, this is a full return. Okay, so we're looking for the index of the segment where x t has now exceeded, and we return the previous one. It assumes an ordered list in x. That is true in the case of our sample. Therefore, when x is 0, we will loop once on this one, less than or equal to. Interesting. Will this return when, so 0 is less than or equal to 0, return 0. This would be correct. When 0 is equal to 2 point, sorry, when t is equal to 2.5, it would check 2.5 is less than or equal to this. That is not the case. It would check 2.5 is less than or equal to this. That is the case. So it would return 0, index 0. That is okay. So we're going to state that heuristically, sorry, I'm doing 2 windows here, so you might not be able to see all of my actions. But yes, heuristically, yes, our segment finding is working. So we're going to assume that we do have our correct segments. We get segment 1 and segment 2. So the 2 points that are neighboring, we're currently in segment 1. We want the next segment. Yep, let's do it. The problem, perhaps, I wonder, part of the problem is right here, because we do segment plus 1, which, in the case of the second point, might loop around too quick. So Find segment T. Find segment T. Find segment of time. So if we're in 0.5, yeah, okay, well, what happens if we exceed the size of the array? That's my question. So if we're at spline point, we're right here. When we get this reference, what does std vector do if we over-index, if we index outside of the array? Let's go find out. Std vector do when the requested index is above the number of points. Yeah, dude. Always change to English. Thank you. Out of range error operator typically does not perform out of bounds. Index checking may include uninitialized memory, crash, fault segment protection, blah, blah, blah. Even if, all right, so is it the case, point set size 0? So if int seg2 is equal to, what's the ternary syntax in this language? Anyway, I'll just write the ternary syntax and I'll let the thing fix it. But it's equal to seg plus 1 if, yes, thank you. Segment plus 1 points at size. Yeah. Else 0. To loop around, baby. That's the idea. So one seg 2. Now the concept here is that if our right, but the current way we've written it is that the nth or the last point is in fact the same as the start point. So we've assumed that in these patterns, point is 0 and n minus 1 are identical. That is true. Huh. Come on, Brian. What's going on here? Seg plus 1 is 0. So this would make sure that we loop back around. Let's confirm in our registry that this is the case. Oh, I'm getting a little bit of lag here, which means you're getting lag. Check our activity monitor. Hello, OBS. Still working. OBS is up. We'll check with the humans. I'm seeing Twitch issues. Gonna refresh Twitch. Hopefully that's just my local Chrome. But am I here? I think I am here. I think it's working. Load up stream. Okay, cool. I see my face, see my stuff. And I'm just gonna pause my video, but hey, should be chill. Okay, I got like 10 more minutes and then I got a jet. Seg 2. So let me just think about this. In the case, yeah, where we're looping through this pattern, end points 0 and n minus 1 are identical. Segment, maybe we simply should not include. Maybe we should simply not include the last point. No, we should include it so the other calculations work. Okay, messy, 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 messy. But we're just trying to get this thing working. Let's keep this here. I am skeptical. I'm skeptical about the need to set 0 based on our current segment, because we should be able to interpolate between those 2 points. Like if we have the last point, n minus 1, then will we ever exceed it? if our time tells us we never go forward, I think that's not the case. We will never exceed, because we're doing a strictly less than or equal to check. Odds of us exceeding are low. We'll just do seg plus 1. I think that is the case, that this will be okay. I don't think our bug is from here. Seg dx return 0. Sure, why not? dt dy. All right, let's go forward with our heuristic. So we are now in this function. We are passing in times 0. We have our two segments. We have 0 and segment 1. We know what these values are going to be at its trapezoid, right? So we know what these 2 points are. We know that dx is going to be equal to, so seg dx is going to be equal to 0.5. That's good. dt is going to be equal to -1. Can we confirm that? dt is equal to time, which we're passing in as 0, minus p0x, which is 0, in fact. Okay, no, it's going to be 0, divided by seg dt, which is 0.5. So 0. dt is 0. d0 is float, absolute float. We're not doing anything with handles. All handles are 0. d1 is also a handle that is 0. So m0 and m1 are both 0. We enter into this function. dt is 0. Float is 0, so that's y and y1. So we know that that is 0 and 1 in our 2 points, because y is our vertical in this graph. This means 2 times dt2 is equal to dt times dt, which is 0 times 0, and dt3 is equal to 0. Interesting. Right. dt squared and dt cubed, understood. So that means we have 1. And sorry, folks, I recognize this turned into AJ does math on camera. So thanks for your patience, but it will all work out in the end. Plus m0, so it's 0 times 0. Sorry, y1 is times 0 times 0. So this is, y0 is equal to 0. What's up with that? Am I crazy? Because y1 is 0.5. Yeah, man, I think there's something wrong with our Hermite calculation. Yeah, that's got to be it. Because that ain't right. Let's go check. So computing a cubic spline from points and handles. Yeah, right. Piecewise polynomials. Sure. I want to do interpolation. Interpolating cubic spline using points and handles. Let's go. We're just going to go from base. I would love cubic spline interpolation. Oh, my computer's going crazy. I'll tell you that. Let's crash Docker here. Let's crash granola. Let's crash Docker. But you know what is not the issue? Granola or Docker. You know what is the issue? OBS. But that's what it is. Get me out of here. All right, buddy. Get rid of this kitten. Well, nuke. Let's go. Bro, no! MATLAB. That's not what I needed. Yeah, okay. Cubic spline interpolation. Let's go. We're gonna check out our Hermite again. Perhaps we have our terminal running and it's causing chaos because it's quite slow. That cannot be the case though. Nope, not the case. Okay. Just slow because we're slow. Uh-huh. Hermite curve interpolation. Very powerful. They're used to smoothly interpolate between 2 points. Okay. P1 is the starting point of the curve and the tangent, direction and speed. Hmm. Valid for all cubic polynomials. The only thing that changes is the polynomial matrix. For instance, if you want Bezier curves instead of Hermites. So our C-style pseudocode is as follows. Oh boy, gotta drop in 3 minutes. Okay. Tangent continuity bias, speed control. I'm looking for, what about the normal splines? Okay, so we have our handles. Where did this Hermite formula come from? I'm holding a Hermite formula that I found during our last. Let's find it. Let's find a reference to interpolating between a cubic spline using the Hermite function. Okay, the formula is, I won't go into the derivation of this, but the bicubic interpolation is a t cubed, b t squared, c t d, where we have 4 points. I'm hoping it will resolve into 2 handles. Cubic Hermite. T is a value that goes from 0 to 1 to interpolate in a C1 continuous way across uniform something. When T is 0, it will always return B. When T is 1, it will always return C. We have A, B, C, D, and T. Chill. I mean, no problem. Where A, I see what you're doing. Okay. Let's validate this against my formula. Already, I do see difference. Okay, so we have our T cubed. Hmm. Wait for enter. Sure. Get index clamped. Uh-huh. Print size. Is this copyable? Great. 1D and 2D data. All right, talk to me here. Our floats A, B, C, and D. How are you interpreting those? So cubic Hermite. Do you call this function? Show me an example. Get index clamped. Get index clamped from points. Okay. You are using a 3-point interpolation. 4-point? You're using a 4-point interpolation. Should I be using 4-point interpolation? Huh. Get index clamped at -1, 0, 1, and 2. That is interesting. Do I require 4 points to correctly compute or interpolate between 2 points of a cubic spline? I did not think so. but this individual suggests possibly. We're going to copy this. I have to do a time check here. We're going to state that current status issues interpolating on cubic spline. Here's a reference to somebody who's doing it a different way. They're using 4 points to interpolate. We're currently using two neighboring points to do the interpolation. The question then becomes, can we do 2-point interpolation of a cubic spline? I'm just going to look that up. 2-point interpolation of a cubic spline. With handles. I mean, I'm seeing 3 as well. Yeah, I'm not a fan of this, reading through this, but let's just check. Given the formula, the general formula for a 2-point cubic spline, given points with these slopes, we compute it. The Hermite spline basis function and multi-point spline scenarios. Resulting spline ensures both the function and its first and second derivatives are continuous, avoiding sharp corners. Implementation. Huh. All right, here's the thing. Spline basis functions. Let's just go check where A is x cubed. Sorry, the spline function, the interpolation function is ax cubed plus bx cubed squared, cx plus d for these two functions with the slopes m0, m1. It is my understanding that we only require two points to do this interpolation. So I'm going to read through that article offline. That suggested 4 was valuable. I wonder if they're just using that to compute the slopes when that can't be the case. They must have a different objective. Okay. Where h is, so we have slope 1 minus, plus slope 2 times 2, the delta and the y's divided by the h. Where h is the delta and the x's. Okay. Over the square. I mean, low key, I'm out of time, but I also just want to implement this really fast just to see. Like, it seems easy enough. Will be, come on, man. You didn't even define, oh, you didn't even define C or D. Get out of here. What a waste. For fitting a cubic spline between 2 points, I don't want to fit, but yeah, I have the slopes, I have the 2 points. Let's go. Polynomial is here. The 2 points are these expressions. The 2 slopes are as stated. Then when x1 is not equal to x2, x is the inverse matrix. Okay, yeah, that makes sense. Where B is the resultant of the matrix multiplication. AX. We have our factors. We have our cubics. We have, this looks like polynomial expansion, question mark. 3x squared. Yeah, it seems to be the case. ABCD. So it's just different organization of those values. But let's go see his generalized formula at the end of this calculation. It does have the same to a degree. So yeah, baby. All right. Absolutely, we have the problem. We know where it is. And I am very tempted to just mess with this right now. What are we going to do? I have my slopes coming in. I have my y points. Do I have my x points? No, I do require them. Confirming. Yeah, I do require them. So let's just change Hermite to take our points and our slopes. T0. What is going on here, bro? Just take the points, man. Let's go. Segment point. There's no need for TT. No, it is required. Okay. Yep. Because between these 2 points, yeah. The notation is driving me a little crazy, to be honest. Because dt means delta t to me, at least. Okay, off screen. I have our factors open. Let's go. Float A, float B, float C, float D. Okay. Float A is equal to M1 plus M2, which is the slopes. So float M1. This is the handle slope. And then float M2. Yeah, it's not the slope between the points. This is the handle. So how were we computing this before? Let's just make sure. It should be handle in temporarily, just to make sure that I can get something. We're going to say this is 0, 0. Because for the trapezoidal function, it is 0, 0. The slopes are 0, 0, but we're going to include them in computation for the purposes of making sure we get shit done right. So M1 plus M2, this is minus 2 times P1y. Yeah, that's correct. P1 dot y. That's P0 dot y. Let's be careful there, pal. What's going on? We need our in fact, I'm a little bit tempted. All right. I'm just gonna do some pre-calcs. So let's do float delta x, float delta y, and we'll do our M0, where M0 is the slope between the 2 points, which is non-zero. Y over delta x. Okay, cool. And that way we can simplify our calculation a little bit. So this is minus 2 times M0 divided by delta x. Thank you. Thank you. That is delta x to the power of 2, my friend. So that is 2. B is equal to the difference in slopes. That is M2 minus M1 divided by 2 times delta x minus 3 over 2 times, and we're just going to be real hyper pedantic about these brackets, times, that is sum of the x's, p0 dot x plus p1 dot x times a, which is defined above, and c is equal to m1 minus 3 times x, sorry, that is x1 squared, p1 dot x 2 times a minus 2 p1x b is correct. I think the robot has figured out what I'm up to. That is not right. So it's P0, P1 dot Y.